Alright, welcome to 3.09. We're going to solve rational equations by hand and using technology. This is something that we've actually really already done in working with Wolfram Alpha and looking at equations of rational, looking at rational functions on Wolfram Alpha. We've already kind of seen how to solve rational equations using technology, so this should not be anything new. What we are going to be doing is getting much better at using rational equations to represent real-world situations and then solving for them using the skills that we've already acquired. So we're going to just finish up this problem that we've been working on. Again, Tom and Russell, after their Super Bowl clash, have taken this canoe trip up a river and then returned. Their current in the river was 1 mile per hour, and the total trip time took them 2 hours and 24 minutes. You're assuming they paddled at a constant rate throughout the trip, and we want to find the speed that Tom and Russell were paddling. So pause the video right now, go back and take a look at the work that you've so far done, and try to solve for the speed that Tom and Russell are paddling. And only once you've given it your best effort and solved for it and written out your answer should you go ahead and press play again, and we'll just kind of wrap this up and talk about it. Alright, so what I want you to do right now is I want you to go ahead and circle the work which you just did, and want you to write that this was your first attempt. So circle it and label it as your first attempt, and now we're going to, I'm just going to kind of talk about it a little bit, and if there's a hint that you think will allow you to make a change or get the correct answer, pause the video and make a second attempt to get the correct answer. Alright, so the big key here is to realize that in order to find the speed at which they're paddling, and maybe we'll call this x, we need to write an equation. So our plan, and this is really a plan that we have whenever there's a missing piece of information, we want to represent it with a variable, and we want to create some equation with it so that we can go ahead and solve for it. So what I realize is that the time it took them is made up of two trips, the trip there and the trip back. So if I think about this, I have the time it took them to go there plus the time to go back, and that's going to be 2 hours and 24 minutes, which is 2.4 hours, because 24 minutes is 40%, 0.4 of an hour. And how do I find the time? Well, time, of course, is distance divided by speed. And so the distance on the way there was 1.3. The distance on the way back was 1.3 miles, of course. And what was their speed on the way there? Well, their speed on the way there was made up of two things, right? There's the speed they're paddling, which is x, and there's the speed of the current. So either the current is helping them, increasing their speed by 1 mile per hour, or decreasing. And so it doesn't matter which way we choose for it to be increasing or decreasing, because guess what? They are paddling at the same rate, constant rate, the entire time. So let's just assume that it helped them on the way there and that it hurt them on the way back. So now all I have to do is solve this equation, right? This is step 1 here, and here it is. I've completed it. So if you haven't already, go ahead and solve this equation here and find your value for x, and then we'll talk about it. So I found our common denominator by multiplying by x minus 1 over x minus 1 and x plus 1 over x plus 1. I get x squared minus 1. And then up top I can collect some like terms. 1.3x plus 1.3x will be 2.6x. And then negative 1.3 plus 1.3 is 0, of course. And so I'm left with 2.6x. And it's equivalent to 2.4 divided by x squared minus 1. And at this point, I have a rational expression, and so now I can get rid of that rational expression. I can turn it into something that I'm much easier to solve for by multiplying by the denominator on both sides. And so now, on the right side of my equation, I have 2.4x squared minus 2.4, and on the left side, all I have left is 2.6x. Alright, so at this point, we're going to try and solve for x, and we have a much easier to work with situation. The easiest thing for us to do is to collect all the x terms on one side, and we're actually going to want to leave this negative 2.4 over here, because when we collect everything on one side, we'll have a quadratic equation equivalent to 0, set equal to 0. So I'm going to subtract 2.6 from both sides, 2.6x from both sides, and I'm going to end up with, and I'm going to write it like this, 0 on the right side, and on the left side I'll collect all of our terms together. So I have 2.4x squared minus 2.6x minus 2.4. And so now I want to solve for x, and there's a couple of ways that I can do this. Right? I can't really factor this equation. This would be kind of tricky, or this expression rather. So what I'd like to do is either use the quadratic formula, or I can use technology at this point. I can use Wolfram Alpha or a graphing calculator. So why don't you go ahead and choose your best option, use it, and we'll check with our answers and make sure that we are clear on what they mean in just a few seconds. Alright, so I use the quadratic formula over here to find the two values that would satisfy this equation, the two roots, and I got negative 0.6 and 1.678. So we get two answers here, but we want to think carefully about which one answers our question. So remember, we're trying to solve for x, and x was the speed that Tom and Russell were paddling. Well, does it make much sense for them to paddle at negative 0.6 miles per hour? Definitely not. So we get what's called an extraneous solution. We've defined that already. And this extraneous solution is one that we don't want to include. Alright, so we're going to go ahead and then only use this solution because this makes sense. I want to only use the solution where they're paddling at a positive speed. So the answer that I'll go with is that they were paddling at 1.67 miles per hour. 10 liters of juice blend, it is 60% pure juice. You're going to add more pure juice in order to change the concentration of the mixture. Determine the number of liters you need to add in order to reach the concentration of 75% and then also a concentration of 45%. So go ahead and pause the video. This might sound a little familiar. We've talked about concentration previously, and this is no different than that type of concentration, although you will need to be mentally focused in order to solve this problem. So understand the problem, what are you trying to find, what do you know, and then create a plan for yourself and execute. Alright, hope that went well. Again, just make sure that your work is clearly labeled. So if you did your work all over your paper, go ahead and just draw a line, point to your work, and then second attempt here. Here the key thing is that we know we're looking to figure out how much pure juice we want to add. So we could call that x. And what we'd like to do is, of course, create an equation in order to solve for x. So the things we know are that we have 10 liters of juice and 60% of it is pure juice. So in hearing that, I now know that I have 6 liters of pure juice in my liquid. And we want the concentration to be 75%. So when I think about all the pieces that I have and wanting to solve for the amount that I need to add, well, what I'm going to need to do is actually compute the concentration of my liquid, and using the amount that I'm adding, and then set it equal to 75%. So what I can think about is that let's just think about where we're at right now. You have 6 liters of pure juice and 10 liters total. Okay, so that's your 60% concentration currently. Okay, now if you were to add, let's just say 1 liter, you would have 6 liters plus 1 more, and your total mixture would be 10 liters plus 1 more. So what you can see here is that the liters you're adding is going to be added on to both the amount of pure juice and the total mixture, and that is going to equal the concentration of the liquid. So the concentration of our liquid is going to be 6 plus X, the number of liters we're adding, divided by 10 plus X. Alright, so at this point we have our equation, and now we're set because we know what we want the concentration to be. We want it to be 75%. So we can use our equation, and we got to be a little careful because C is the concentration of the liquid, but it's not written in percent, right? We use a decimal to make sense of the concentration when we're dividing. So 6 divided by 10 is 0.6. That would be our concentration here. So for 75%, my concentration is 0.75, and that's equivalent to 6 plus X over 10 plus X. So go ahead and pause the video now and solve the equation, and then press play, and we'll talk. Alright, so hopefully you were able to figure this one out. This is not too tough. The really tricky part is actually writing the equation. We're going to multiply by the denominator on both sides. Those, of course, will cancel because it's 1 over 1. So now I have 7.5 plus 0.75x equals 6 plus x. I just distribute it in. I'm going to collect all of my like terms onto one side, so I want to get all of the x values, x variables, onto one side. So I subtracted 0.75x from both sides. That gave me 0.25x. And then I subtracted 6 from both sides, which gave me 1.5. And then I divided by 0.25 and got x equals 6, because 0.25 goes into 1.5 6 times. There are 6 quarters in $1.50. And you could check this out. You could go ahead and plug 6 back in. So if you went 6 plus 6 is 12, divided by 10 plus 6, which is 16. And sure enough, 12 divided by 16 is 3/4, because there's a 4 in each term that cancels, and 3/4 is 75%. So that's what I need to do for 75%. Now go ahead and do this on your own now for 45%. Okay, I hope that went well. We'll discuss this a little bit in class, but hopefully you were able to solve, and I want you to think about why your answer makes sense. So what type of answer would you expect if you wanted your concentration to be 45%? Important to remember that originally it was 60%. And go ahead and write out your answer and explain why it makes sense. Got one more problem for us to try. Let's take a look. Alright, Hector walks 3 miles to a friend's house and returns home on a bike. He averaged 4 miles per hour faster when he biked than when he walked. his entire trip took 2 hours, what was the speed at which Hector walked? Now, I know what some of you are thinking. We know Hector, we know he didn't steal the bike. His friend loaned it to him. So you can stop thinking about that right now. What we want to do is create a plan for how we're going to solve this and figure out what the speed was that Hector walked. So pause the video, give it a try, go through it. Make sure that you label your first attempt on your paper or split your paper in half. I'll give you a couple hints, but for the most part, I want you to do this on your own. So the plan that we want to have, as usual, is to create an equation where the speed that Hector walks is our variable. So let's actually call that W, his walking speed. And this is very similar to the problem with Russell and Tom in their canoe. So we know the total number of hours that it took. So maybe that's a hint. Go ahead and pause the video if it is, and go ahead and work your way through it now that you know this. But so if you think about the 2 hours that it took, well, that was made up of the time that it took him to get there plus the time that it took him to get back. And so you can calculate the time it takes him to get there. Well, it's the distance he traveled divided by his speed. I'll leave the speed blank for a second. And the time on the way back was the distance he traveled, 3 miles, divided by his speed, and that all had to add up to 2. So think about what his speed would be on the way there. Well, what did he do on the way there? He walked. So his speed is W. Now, on the way back, he biked. Well, how fast was his biking speed? You might be tempted to put, a variable B for his biking speed. But you know something about his biking speed. When he biked, he traveled 4 miles per hour faster than when he walked. So his biking speed, imagine that were some variable B that we don't know. Well, his biking speed is just the speed he was walking at plus 4 miles per hour. So we can represent this as W plus 4. And now we have an equation, and all we've got to do is solve for W. So at this point, I'm going to leave you be. You're going to solve this, if you haven't already, on your own. Write up your answer. I'll be looking for it. But I also want to give a shout out to second period, which has done a truly tremendous job, each and every one of them. So keep up the good work, and I'll see all of you guys on Wednesday.